The purpose for this project was to design, develop, and manufacture a cost-efficient and reliable leak detection device or AC system that will improve current leak detection methods. The key technical objectives given by our sponsor, Champion AC, included the ability of detecting refrigerant leaks. Testing time must not exceed 2 hours. It had to be unreactive to refrigerant 410A, and it had to be single-user operated. The key functional requirements for our design were the following. The nozzle should increase the effective detection distance from 0.5 inches to 5 inches. The device must allow for the detection of leaks present in hidden components. The NFA should detect the presence of refrigerant from any angle relative to the leak. The device must function properly in potential environmental conditions. The nozzle fan adapter was designed to create a current of air to bring the refrigerant to the sensor tip of the halogen leak detector. CFD simulations were done in ANSYS to select the most efficient dimensions for the body. The goal was to reach an airspeed of 1 to 2 inches per second on the sensor tip, because the sensor device detects the refrigerant more accurately at this speed.
For the analysis, as previously mentioned, CFD simulations were run in ANSYS to obtain the selected geometry. The general shape was already defined, however, the specific dimensions of it were to be decided. There were 3 parameters that were going to be analyzed: the entrance shape, the internal diameter, and the fan at which the angle at which the fan rested. There were 3 different entrance shapes, 3 different internal diameters, and 5 different angles. The criteria for selection was the one that provided the lowest airspeed, which was around 1 to 2 inches per second according to the specifications of the sensor. After running the simulations and plotting the data, a curved entrance shape was selected and a fan angle of 130 degrees was selected as well. The internal diameter was the only outlier in the sense that the lowest airspeed was not selected. The reason for this is the lowest airspeed was the largest diameter. However, that will greatly decrease the probabilities of encountering a refrigerant particle. For this reason, and because the next highest airspeed was not too much of a difference, an internal diameter of 18 millimeters was selected.
So to make the NFA, we chose additive manufacturing, commonly known as 3D printing. You can see that the material we chose is known as PETG for the solid black parts, and the flexible gray parts is known as TPU, a thermoplastic polyurethane. Each piece takes roughly 1 day, 8 hours to manufacture. So during our discovery phase, we had anticipated a total cost of $1,400 to complete this project. However, after narrowing down the scope to this type of method, we got our cost down to $280. So each NFA costs us roughly $56 to produce. Roughly $4 in 3D printed parts for PETG, $8 parts in TPU prints. The Elitech leak detector sensor is $30, and the Nozzle Fan assembly is $14. Now, the total hours that we put into this, engineering-wise, we spent $270 over since Senior Design 1 and Senior Design 2. Roughly 120 hours of technician work, 240 hours of secretary work for our class deliverables, 69 hours in labor, leading to a total cost of over $50,000. As for our schedule, we are hoping to have the final assembly unit completed at Champion AC by the end of April.
In conducting 40 tests, 3 were deemed as the most critical, which were increased range of leak detection, enhanced angles of leak detection, and increased leak detection of hidden AC components. For the increased range tests, results showed almost double the distance to detect a refrigerant leak when using the nozzle fan adapter. For enhanced angles of leak detection, results showed an increase in detection ability for locations perpendicular to or above the source of the leak. For the increased leak detection of hidden AC components, they show that when using the nozzle fan adapter, A leak was detected within the evaporator fins and coils. When using just a leak detector by itself, no refrigerant was able to detect this leak from within the coils.
Based on the obtained results both from the testing and from the analysis, it can be concluded that the nozzle fan adapter increases the range of current leak detector sensors. This makes the inspection of large residential areas much faster and efficient. As well, it also allows the user to detect leaks that come from inside AC components, thus making previously unreachable leaks now detectable. This project was underwent and took the feedback from both the sponsors and the technicians, ensuring that all of their comments were taken into account. It was done well under budget and on time.